Today, we're covering one of the most difficult yet rewarding topics that every TIG welder must learn: aluminum TIG welding. Aluminum welding might look easy from the outside, but in reality, it's a process that requires true mastery. In this video, I'll explain how to do aluminum TIG welding step by step in a clear and simple way. Before starting to weld, it's essential to know this: aluminum itself melts at approximately 1220 degrees Fahrenheit. But the oxide layer on top of the aluminum melts at over 3632 degrees Fahrenheit. So when you start the weld, the base material is ready to melt, but the oxide layer is still there. That's why a current and technique that can break through the oxide layer is essential in aluminum TIG welding. Otherwise, there's no penetration, the bead spreads out, and the weld looks dirty. For aluminum TIG welding, the welding machine must be set to the alternating current position. The role of AC is this: the positive phase cleans the oxide, and the negative phase provides penetration. Without alternating current, you can't weld aluminum. 100% pure argon is used as the shielding gas. The gas flow rate should generally be 20 to 30 cubic feet per hour, about 10 to 15 liters per minute. Low gas flow causes oxidation, while excessive gas flow leads to turbulence. High-frequency arc starting provides a very clean and stable start on aluminum. In aluminum TIG welding, the AC balance directly determines the quality of the weld. As a general starting setting, it should be 70 to 75% electrode negative and 25 to 30% electrode positive. This range ensures adequate oxide cleaning, solid penetration, a stable arc, and long tungsten life. If too much electrode positive is used, the tungsten overheats, the bead spreads, and control becomes difficult. If too much electrode negative is used, the oxide won't be fully broken. Because of this, the bead will look dirty and dull. The goal of the AC balance setting is to provide sufficient cleaning and controlled penetration. The alternating current frequency determines the character of the arc. Low frequency provides a wider bead and a softer arc. High frequency, on the other hand, provides a narrower, sharper, and more controlled bead. Using high frequency is preferred for thin aluminum. For thick aluminum, however, low frequency may be preferred. The amperage setting should be made according to the material thickness. As a general rule of thumb in aluminum TIG welding, about 120 to 150 amps should be used for every 1/8 inch of material thickness. For example, 120 to 150 amps for 1/8 inch aluminum and 170 to 220 amps for 3/16 inch aluminum is a good start. For those using the metric system, the equivalent of this rule is about 35 to 45 amps for every millimeter of material thickness. The most commonly used tungstens in aluminum TIG welding are green, white, blue, yellow, and purple tungstens. These tungstens operate more stably in alternating current. Red and gray tungstens are generally not preferred for aluminum TIG welding. These tungstens are more suitable for stainless steel welding in direct current. 1/16 inch tungsten is common for thin materials, while 3/32 is used for thicker ones. In transformer machines, the tungsten tip naturally forms a ball quickly due to the alternating current. That is why it is used with a ball tip. In inverter machines, the tungsten tip is mostly blunted. It's sharpened, but with a tiny flat surface at the end. This makes the arc narrower and more controlled. Tungsten stick-out is usually kept around 1/8 of an inch in standard nozzles. With a gas lens, the tungsten can extend up to 1/4 or 3/8 of an inch due to better shielding. The biggest enemy of aluminum TIG welding is contamination. Before welding, always brush the surface with a stainless steel wire brush used only for aluminum. Clean off any oil and dirt with acetone. Filler rods should also be wiped with acetone before welding. The most common filler rods in aluminum TIG welding are ER4043 and ER5356. ER4043 is more fluid and is preferred for thin materials. ER5356, on the other hand, provides higher strength. This makes it the choice for structural and load-bearing parts. Choosing the wrong filler rod can increase the risk of the weld cracking. Aluminum conducts heat very quickly. Using a foot pedal, the amperage is quickly increased at the start to easily create the weld pool. As you proceed and the material heats up, the amperage is gradually lowered to maintain control. This reduces the risk of overheating, weld spread, and burn through. Using pulse current provides an advantage in thin aluminum. Pulse current raises the current briefly and then lowers it, allowing the part to cool slightly. This reduces heat buildup, warping, and the risk of burn through or melting. The weld becomes more controlled and aesthetic. The torch should generally be held at a 10 to 15 degree push angle with a short arc length. A short arc length provides a cleaner and more stable arc. A long arc length disrupts gas shielding and widens the arc, making control difficult. For thick aluminum, preheating to about 150 to 250 Fahrenheit and using a copper backing is a huge plus. Preheating reduces the part's tendency to draw heat away at the beginning. This allows the pool to form faster and makes the arc more stable. The copper backing balances the heat and supports the workpiece. It helps shape the weld, especially on the root side. This increases penetration and reduces warping as the heat spreads more evenly. Filler wire should be fed into the weld pool rhythmically and in a controlled manner within the gas shield. If the wire goes outside the gas shield, it oxidizes, and this oxide is carried into the pool. This causes porosity and results in a weak weld. Therefore, filler wire should be pushed rather than pulled, and the wire tip must always stay within the gas shield. In summary, when you use the right settings and technique in aluminum TIG welding, you get top-level results in terms of both appearance and durability. In this video, we explain step-by-step how aluminum TIG welding is done. If you think this video was helpful, don't forget to like it and subscribe to the channel for more TIG welding training. See you in our next video.